Okay, in this today's agenda, we are going to talk about all these 5 concepts in the. Yeah. Is it fine now? Is it fine now?
Yeah, it's great. Yeah, thank you very much. Yeah.
Okay. Okay. In this today's agenda, we are going to talk about all these 5 concepts of the SQL Server architecture: internal architecture, SQL Server services, physical architecture, and database file placement strategies, and SQL Server Management Studio. We're going to talk about all these, 5 concepts today. And before going to the first concept, SQL Server internal architecture, let me go to the box, actual server. Hope everyone joined now. Can you hear me, guys?
Yes, yeah.
Let me see. Yep, everyone there now. Okay. And I opened, everybody is familiar with this, task manager. Where you see the actual process in the task manager, if somebody is saying, even OS guys used to get the details of our memory consumption from the task manager or SQL Server, SQL Server.exe. This is the one which is the main memory, of our entire SQL Server. And I'm going to talk about internal parts of the SQL Server exe file. Okay. And there are some layers. I'm going to talk about them now. And let's see. And it may be something similar to the Oracle, but don't be with the fresh mind. Don't compare with the Oracle for some time. Let me open it. Are you able to see this now?
Yeah, I can.
Yeah. In SQL Server internal architecture, which I'm going to talk about more about memory actually. And you cannot see everything in this one, and you can see some of the components of protocol layer and relational engine and storage engine. Actually, you cannot see everything is in there in SQL Server.exe. You cannot see them actually. And let me start with the protocol layer. And we do have 3 layers in our SQL Server internal architecture: protocol layer, relational engine, and storage engine. And let me open up this PPT. In this protocol layer, we have you know about the TCP/IP, and it's one of the protocol in the SQL Server which we use to connect to the SQL Server from outside, which means like our listeners in Oracle, we used to connect through TCP/IP. And there are some other 2 protocols: shared memory and named pipes. Shared memory is a simple protocol which is used for only to the particular box. It is a protocol. Don't compare it to Oracle shared memory. It's a shared memory is a protocol which is if your client is installed in the same box. If your client is installed in your same box, this is the shared memory protocol actually. If your client also installed in the same box, you can use this shared memory protocol to connect to your SQL Server. And the second one is named pipes. Named pipes also another protocol. If you are in the same LAN, I'm talking about the WAN actually, LAN. if you are in the same LAN of the SQL Server machine which your database is running, you can use these named pipes. Though you can use for WAN also, but it's not recommendable option. By default, this named pipes is disabled, and if you want to really use that named pipes protocol, you need to enable that one. And TCP/IP is very familiar in SQL Server. This is a widely used protocol in SQL, in SQL Server. And the default port number this TCP/IP is 1433. And named pipes also use 1445 port, but this one is not recommended through WAN, only through the LAN actually. So you got all three protocols used in the SQL Server, and we'll be talking more about TCP/IP in later parts. And it will be using 1433 port. You need to make sure when you're installing your SQL Server, you should have 1433 enabled in your firewall and also in the network. The port 1433. Okay. And another one is SQL Server network interface. This SQL Server network interface will be there in the client side as well as server side. This is a client, machine, and this one is a server. And this SQL Server network interface will be there in the client side and also server side. This SQL Server network interface, no need to install anything. If you are using your protocol, it will automatically configured in your client and as well as server. So SQL Server network interface is the main component in your protocol layer through which you use to send your SQL commands. Suppose let me start with a simple SQL command here. If you are using your SQL Server client or you are from the user end, if you fire a SQL Server SQL command, first it will reach your client SNI, SQL Server Network Interface, which is nothing but one of the component of your protocol layer and your TCP/IP. And through this, if it reaches the SQL Server Network Interface, it uses one mechanism to wrap this SQL Server command. It will wrap this SQL Server command using tabular data stream. Using the tabular data stream mechanism, it will wrap your SQL Server command and it will send it to the server through TCP/IP. In the server, you do have SNI, SQL Server Network Interface. There, TDS will be there, SQL Server data stream actually it is, tabular data stream, and it will be having some endpoint here. Here, it receives the packet from client to server, and there it will unwrap the TDS packet, tabular data streaming. It's not actually a kind of encryption, but it is a format through which TCP/IP receives, SQL Server command. So one of the format actually, tabular data streaming format. So after unwrapping this, it will again become a SQL command, and it will go to relational engine. And in relational engine, we do have the SQL command will reach the storage engine, and it reaches the command parser section actually. The command parser, this command parser will do first a syntax check. If it finds any syntax error in that SQL command or SQL query or TSQL query, anything, it will send back that command to the client, and it will show the syntax error. Fine. If it is a SQL statement, select statement, what will happen? After checking the syntax, it will look for an execution plan. First, it will go to the storage engine buffer pool. In that buffer pool, we have plan cache and data cache. Plan cache is like SQL Server library cache, in Oracle, it's a library cache, same as plan cache. So it will check for the plan cache if already execution plan exists or not. If it is not there, it will create an execution plan, and it will create execution plan. It will make it as a query tree. Query tree means each node of this query tree represents operation in the query. Whatever operation is doing in that query, it will be representing at a node, and it will send it to the optimizer. Optimizer is a main area in SQL Server internal architecture. What this optimizer will do, once it receives a query tree, first it will do, let me open a notepad. It will do a pre-execution check. In this pre-execution check, if it feels that it is a simple query, simple select statement or simple query, and it will make it as zero cost or trivial, zero cost or trivial execution plan. Suppose this optimizer finds in this query tree maybe loops, nested loops, and something else, some complicated SQL query if it finds in this query tree. What it will do, it will start doing three phases. In three phases, it will filter this query tree actually. It will plan this query tree in the three phases. Phase 0, phase 1, and same way, phase 2 and 3. We call this pre-execution check as phase 0 actually. And phase 1, 2, 3, in phase 1, it will check for the nested loops, and 2, it will try to impose the optimizer rules on that one, and phase 3, it will do a final check, and it will make it as a query plan and send it to the query executor. Let me repeat this. After receiving a SQL command parser will check for the syntax, and if there is any syntax error, it will send it back to the protocol layer, and no syntax error, it will check for the execution plan, is exists in the plan cache or not, and no execution plan exists, it will try to create execution plan and make it as a query tree and send it to the optimizer. What is query tree? Query tree is having each node, and each node of this query tree represents a SQL query operation. And after receiving this query tree, optimizer will do a pre-execution check, which is we call a phase 0. In this, it will check for it is a simple SQL query or it's nested, and it's a complicated one. It's having nested loops and all these things on top of the SQL query. If it feels that it is a SQL, simple SQL, it will make it, we call it as a query or zero cost or trivial execution plan, or else it will go through the phase 1, 2, 3 checks. In phase 1 check, what it will do, it will check for a nested loops and complicated things on top of the SQL query, and then in the second phase, it will impose optimizer rules. What are those optimizer rules? This is as a cost-based optimizer in SQL Server. Its algorithm is hidden internally to the Microsoft, and nobody knows this algorithm. But this algorithm, optimizer algorithm, will do these 3-4 phases. It is not even to the some of the Microsoft people doesn't know about this algorithm actually. It is an undocumented thing. So that's where they know their bread and butter comes. Bread and butter comes actually. That is the main thing, main core area of SQL Server architecture optimizer. So phase 1, 2, 3 checks it will do, and it will create a query plan, and it send it to the query executor. Query executor job is send this query to the access method and to the storage engine. It will send it to the access methods. Through access methods, it will send it to the storage engine. These access methods means nothing but a set of programs, APIs, set of programs actually, not APIs, set of programs inside this, SQL Server internal architecture. And through these programs, it will go to storage engine. Are you clear with the relational engine? Please let me know if you have any questions on relational engine. Any questions on relational engine? Ajay, Arun, Murali, Sandeep, Satish, Senthil, Srinivas. Okay. Through these access methods, suppose I say it's a select statement, what it will do, it will go to directory buffer manager. Buffer manager deals with buffer pool in storage engine. This buffer pool contains plan cache and data cache. And this data cache is main memory component in, memory consuming. It's a major thing, occupying thing in memory, data cache. Through this buffer manager, it will try to check the page is available in buffer pool or not. If it is unable to find a page in buffer pool, it will send, the buffer pool will interact with the data files and get back to and get the SQL, the required page, and it do the operation and we send the output back to the SQL Server client. Suppose if it is a update statement, what this buffer manager do? Again, after checking the data page, it will go to the transaction manager. This transaction manager deals with transaction log data files, LDF files. So everything which you are updating, inserting, that should be recorded first in transaction log data files, even before buffer pool. Even before buffer pool, it should record in transaction log data files. After recording in transaction log data files, using the lazy writer, it will modify the page in data cache and it will set a counter. It will set a counter to it. I'll let you know what is that. And this page will become dirty page. This page will become dirty page. After that, there will be a timing for this one, checkpoint, or every 1 second, it will be writing through the data files. The modified page, dirty page, will be writing to the data files. After writing to the data files, the counter clock will start. This page will become free page. Suppose the counter clock ticks from the 1000 to the 0. After becoming a 0, lazy writer will flush this free page. This is called aging. This is called aging in SQL Server. Let me repeat this. After getting a query plan from the relational engine, if it is select through access methods, it will go to the buffer manager. From the buffer manager, it will check for the data cache. If it is not there in the data cache, it will get from the data file and it will send it back. After doing the operation, it will send it back to the client. If it is an update statement, first what it will do, through the transaction manager, it will record that update in transaction log data files. After that, it will come to the data cache and again get the data file. And if it is not there, it will get from the data files and put it there and do that operation there, and it will become dirty page. Along with that, it will mark for the counter. After 1 second or a checkpoint, the lazy writer will write it to the data files. After that, the dirty page will become free page. And the age of this free page will be decided by the 1000 seconds. Suppose if it is 1000 seconds, if it is 1000 seconds, clock will tick till 0, 1999 till 0. After becoming 0, the lazy writer's job is to flush these free pages. Any questions on this, guys?
Yeah, Pawan, actually, what we are recording in the transaction log, it's the SQL query or it's the after image data kind of thing?
No, it is after image data actually. It will not record actual data. It will record same thing like in Oracle. It will just record the after image data. After image, what it is doing operation, it will write it there. Minimal data will be written there.
Okay. Thank you.
It's a confusion. If you have any confusion, let me briefly go through entire thing once. Protocol layer from the yeah, Murli.
It won't take any before image.
It will be there. Sorry, it will be there. The transaction log data, what it will do, it will do the undo and redo both things in a SQL Server.
Okay.
The minimal data will be written to the transaction logs.
So Pawan, but there is no rollback in the SQL Server, right?
Yeah, it will be from. There is no rollback. That is correct.
So what's the purpose of taking the before image data?
Before image data means the rollback means through the data cache only it will do. So it will put the actual before image in data cache. Let me make it clear. Sorry guys, let me make it clear here. From the transaction log manager, it will just record the whatever modification it is going to do in transaction log data files. Okay. Rollback in the sense, I think it was Arun or Ajay.
Ajay, yeah.
Ajay, yeah. At the time of recovery, the same like Oracle, it will try to do a roll forward and roll back operations also. If I'm not wrong.
Okay.
So minimal before image will be there in the data cache. It will be there in the data cache until unless the actual dirty page will become a dirty page and write it to the data files. The commit happens. Are you clear with that?
Yeah. Okay. So what process writing dirty page from memory to the data file?
Lazy writer and also checkpoint. Checkpoint also writes. The lazy writer job is 1 second, every 1 second it will try to write. And checkpoint is whenever checkpoint happens, it will write it to the data files.
So,
But additionally, unlike Oracle, we have no two data DB writers here. No 2-3 data writers here. Checkpoint and also lazy writer. These two will do the data writing in data files.
so how the checkpoint is happening, Pawan, in SQL Server?
Same way like Oracle actually. Same way like Oracle, checkpoint will happen, where, and transaction log manager is having two components here. Same like Oracle, we do have a locking and logging. Logging will deal with the transaction log, and locking will deal with the actually update log, update and like a TXTS logs. The locking will deal, transaction log will deal with the locking concept. So checkpoint and lazy writer will deal with the data file writing, and additional job of the lazy writer is checking the counter clock on data cache and flushing the free pages from the data cache. Are you clear with this?
Yeah, okay. I didn't understand the locking concept, why it is that like.
You should log the transaction in a transaction log. Whenever a table, writing the table, you should log the table, right?
Okay, so when it is logging, like when we are running some update statement, so can multiple users like in Oracle do the updates, right?
In the same way we can do the structure is same like when it comes to the locking, the same like our Oracle. We may get deadlocks here, we may get blocking sessions here, and we need to resolve the blocking sessions in SQL Server also. Is a frequent issue in SQL Server is blocking sessions. Over the years, I see blocking sessions is a frequent issue in the SQL Server. And deadlock also you will get in the SQL Server. It will automatically resolve like Oracle. And for that you need to trace. It will not write in your error log. But for tracing the deadlocks, you need to enable tracing in SQL Server. Trace events. There is no difference when it comes to the locking concept.
Pawan, actually logging in terms of the transaction log, yeah?
No, I am not talking about transaction log. I am talking about the object wise.
Okay.
So, in the SQL Server, internal architecture, we see protocol layer, relational engine, storage engine. And apart from these three, we have another one which we call, another component which we call SQL OS. SQL OS is introduced in recent editions. I think it's 2005 somewhere it introduced SQL OS. It is nothing but a set of APIs. And the main aim of SQL OS is reducing the contention on OS. Suppose some scheduling if you are doing in SQL Server, the scheduler will try to reach first SQL OS, and it will try to execute APIs, the SQL OS APIs in SQL in OS level to do the task in from the OS end. Its main aim is whenever you install SQL Server, SQL Server, and you start the SQL Server, it will automatically grab OS level APIs with it, and then it will try to do the SQL Server related scheduling, especially scheduling tasks, and as a job of OS, we need to, in Oracle, if you take the export in Oracle, it has to go through the OS, and then, comes back to the SQL Server, right? Oracle, right? For export, taking the export. And same way, to decrease the contention on the OS, SQL Server OS is introduced, and APIs, OS level APIs will be allotted to the SQL. It will interact with the SQL Server OS level APIs, and it reduces the contention on the OS, and the OS job will be doing by the SQL OS. Some particular OS level tasks also does by the SQL OS in order to reduce the contention on OS. You got it clear? Please let me know if you have any questions on this. Okay. So these are the main three parts, and along with the SQL Server OS, the protocol layer, let me briefly go through it. The SQL command will come to the SQL Server client side SNI, SQL Server network interface, TDS. It will become a wrapped TDS packet. TDS will do the wrapping here, and from that it will reach server side SNI. Some server side SNI, the TDS endpoint will make it as unwrapped TDS packet. Unwrap it will become a SQL command. It will go to relational engine. It will go to command parser. It does the syntax check. After that, it will look for the execution plan. It will go to the plan cache and create an execution plan and make it as a query tree and send it to the optimizer. Optimizer will check for the trivial or zero cost, phase 0 check, and if it is not a trivial or zero cost, it will go for the phase 1, 2, 3 checks. Then finally, it will make it as a query plan. The query plan will go to the query executor, and query executor will send this to access method. From access method, it will go to buffer manager if it is a select query directly, and go to the data cache. If it is not there, go to the data files and send it back to the output to do the execution and send it back to the protocol layer. And if it is a insert statement, go to the transaction log and write it there, record it there, and get it to the data cache. And from data cache, make it as a dirty page. From the dirty page, it will, the lazy writer or chuck point will write in the data files, and output will be coming back to the client. And SQL OS, SQL OS is a set of OS level APIs. It supports the, it uses to reduce the contention on OS. That's all with the SQL Server internal architecture.